Ever wonder why objects fall to Earth? Well, if you have, then this is the video for you. Welcome to TLDR, Newton's Law of Universal Gravitation. Now, any two objects with mass will experience an attractive force between them known as a gravitational force. This force is the reason why we have gravity here on Earth, and it is determined by Newton's Law of Universal Gravitation. Newton's law of universal gravitation shows us that the gravitational force between two objects equals the universal gravitational constant g multiplied by the mass of the two objects divided by the distance between the two objects squared. This relationship shows us that if we double the mass of one object, the gravitational force will double. But if we double the distance between the two objects, then the gravitational force is reduced by a factor of 4. Now, as always, if that summary isn't enough for you, then in today's episode of TLDR, we go into more detail of Newton's law of universal gravitation, and I will show you how to calculate the gravitational acceleration on Earth. So you've probably already heard of the story that Isaac Newton was sitting under a tree and an apple fell on his head. Well, we aren't about that history stuff at TLDR, so this isn't the video to learn about that. But let's jump on to some of the important stuff. Now, in the previous episode, we determined that force equals mass times acceleration. So when the apple did fall from the tree, we know that the Earth is imparting a force on the apple, causing it to fall. Now, the key part of Newton's law of universal gravitation is that the apple also pulls on the Earth with the same force as the Earth pulls on the apple. So, if this is the case, then you may ask, why doesn't the Earth move towards the apple? Well, it actually does, but because the Earth is so heavy, we don't actually experience that tiny acceleration. Now let's move on to two much bigger objects. Let's say the Moon and the Earth. We've already determined that the Moon pulls on the Earth with the same force that the Earth pulls on the Moon with, but there is one key piece of the puzzle that's missing: distance. Okay, now this is an important part as well. When we talk about distance, we're referring to the center to center distance of two objects, just like the diagram on the screen at the moment. We now have all the background knowledge we need to discuss the formula to calculate gravitational forces. So force is equal to the universal gravitational constant g times by the mass of each object, all divided by the distance between the two objects squared. Now, don't get too caught up on the universal gravitation constant. It's simply a constant that relates the force to the mass and the object-to-object distance. It is a very small number with a value of 6.67 times 10 to the negative 11 Newton meters squared divided by kilograms squared. Okay, that's all pretty simple so far. Now let's go back to the apple falling from the tree. What acceleration does that apple experience as it's travelling towards Newton's head? We know that the Earth roughly weighs 5.97 times 10 to the 24 kilograms, and we also know that the radius of Earth is approximately 6,371 kilometers, or 6.37 times 10 to the 6 meters. We can now go back to the equation that we derived earlier and put in our values. First of all, let's keep the mass of the apple as a variable and input the mass of the Earth as well as its radius. When we solve this on our calculator, we can find that the answer is that our gravitational force is equal to 9.81 times the mass of our apple. So as we discussed earlier, this is in the form of F equals ma, and we've determined that the acceleration on the surface of the Earth is equal to 9.81 meters per second squared. Now this is generally represented by a lowercase g, and we will use this in future episodes when we look at projectile motion. So you've now learnt the formula for calculating gravitational force between two objects and proven that the acceleration due to gravity on Earth is 9.81 meters per second squared. So click on the box on the left to watch a tutorial calculation on this topic, or the box on the right to learn about straight line motion basics. Otherwise, check out our channel for more videos or leave a comment down below if you have a topic that you want us to cover in a future episode. Thanks for watching, and see you next time.